Hello, I'd like to talk about the law of acceleration. Okay, and so the law of acceleration is going to tell us how forces actually create motion. Okay, so we talked previously that if forces are balanced, then something will either keep moving in a straight line or it will stay put, right? One of those two. So if you were to say have something that was staying put and you wanted to get it to move in a straight line, you'd have to somehow have unbalanced forces. So what you end up with is this law of acceleration, which is going to say that an object's acceleration, an object's is proportional to the unbalanced part of the sum of the forces. So that means a force can be partially balanced and it will still accelerate some, right? Not as much as if it were completely unbalanced, but if it's partially balanced, then just subtract off the part that's opposing it, and then keep on running. You keep on accelerating with the remainder. And it's also, there's a resistance to acceleration, so it's inversely proportional to that resistance. And that resistance is sometimes called the inertia, the resistance to acceleration. And that is actually quantified by the mass. So the mass is sort of the amount of an object you have, the amount of stuff in an object. That's one way to count the amount of stuff is the mass. Another way would be the volume. But this mass thing, how much something weighs, actually is what keeps your acceleration from happening when you have unbalanced forces. And the acceleration is just the change in the velocity, right? We'll talk a little bit more about that in the next segment. So what does this mean? Well, this means if we have an acceleration A, right, it's resisted by the mass, that's 1 over m. So this is the mass of the object. That's your acceleration. And then it is directly proportional to the sum of the forces. Now these forces can be positive or negative depending on which direction. And here there are n forces. And this is the sum of the forces. So a negative force tends to balance out a positive force, but the negative just means what direction the force is pointing, right? So that if you have somebody pulling this way and the floor resisting that with friction that way, they both have a positive magnitude, but because this one's in the opposite direction, it cancels out some percentage. So let's say it's smaller than this. So it cancels out this part, right? So this part isn't active, but this little tiny bit here is the leftover part of the force. This is the unbalanced part of the force that's causing that acceleration. And depending on how much mass there is, you reduce that even further. Right? So normally we scale this to 1 kilogram or 1 pound, depending on what system we're on. So we look at 1 pound of force versus 1 kilogram of mass or something. So, and this is the mass. So we have that as the force, and just to sort of look at that, let's look at a sailboat. So we've got a sailboat we're looking down at. Let's pretend it's going this way, pointing like this. What do we know about it? Well, let's say the sail is pushing with the wind this way. So this is the wind is pushing this way, wind. And then the hull is going to drag it as well. So let's just pretend it's straight back. Let's say it's going in the same direction. It doesn't have to go in the same direction, but let's just pretend it is. So you have a hull drag, which is in the opposite direction of the velocity, not the direction of the boat. But the keel is always perpendicular to the boat, and that's always going to stabilize it somewhat from the push of the wind, right? And so we've got some hull pulling it back. We have some keel keeping it straight, but not completely. So we have a little tiny bit of net force, a little tiny bit of total force. That's equal to the mass times the acceleration here, right? So this is the unbalanced part of the force right here, and it's going to accelerate the boat a little bit to the starboard, to its right. Okay, looking like this. So the keel and the hull are trying to balance out the sail, but it's not quite enough. All right, it's not quite enough in this particular case. In some cases it will be, in some cases it won't be, but in this case it's not. And if the sail was in the same position and the wind were constant, it would move to a point where they balanced, because these drag forces are proportional to the speed of the boat in the water. Okay, so that is part one. Next, the example.